Hello, welcome to homework questions 90 through 94 on chapter 2 of algebra. Question 90, explain what the slope of each line below represents, then find the slope and give its units. On the first one on part A, you got to make sure that you are looking at the x and y axis. So the y axis is the height of an unlit candle in centimeters, and the x axis is the time in minutes. So when you write when you explain your slope, you need to make sure you do it in terms of the change of y, which is the height of the unlit candle, in terms of the change of x, which is in your minutes. So the slope of part of the first one would represent the change in height of a candle per minute. Alright, so I wrote that down, and then also it does say find the slope and give its units. So the slope, you can see on A, is horizontal, so therefore the slope is 0, which means 0 centimeters per minute. On B, we have water in a storage tank, gallons, over the time in months. So what would the slope of this one represent? It represents the gallons per month of water being removed from a storage tank. And so then I went ahead and calculated using the x-intercept at 10, 0 and the y-intercept at 0, 9,000, and calculated the slope. And I got 9,000 divided by negative 10, which is negative 900. So what does that represent? Once again, that's negative 900 over 1. So that's the number of gallons that is being removed per minute from the storage tank. So negative 900 gallons per minute is being removed. Question 91, find the equation of the line that goes through the 2 points. So we'll start by finding the slope, which is the change of y over the change of x, delta y over delta x. 70 minus 10 would be the change of y, and negative 15 minus 5 is the change of x. So it looks like we get 60 over negative 20, which reduces to negative 3. And then we can use our slope-intercept form and pick one of the points and the slope that we found and plug that information in. So 10 is equal to negative 3 times 5 plus b, and then we can calculate the b value and solve for b by adding 15, and it looks like we get b is equal to 25. So therefore our equation is y equals 3x plus 25. Y equals negative 3x plus 25. So once again, finding the slope and the y-intercept to be able to write the equation of the line. Question 92, there's a checkpoint right here for evaluating expressions and the order of operations. And so at this point in the textbook, it is strongly recommended that you're able to successfully complete these types of problems. So let's go ahead. There's quite a few of them on the checkpoints. There's 6 of them, so let's go through each of these. 2 times negative 2 plus 3 times negative 3 plus 5. So all we're doing is taking each of the variables and plugging in the numbers for them and then evaluating using the order of operations. So negative 4 minus 9 is negative 13. Negative 13 plus 5 is negative 8. For part B, we have x minus y, so that's negative 2 minus a negative 3. Negative 2 minus a negative 3 is a positive 1. On part C, 2 times x plus y, so that's negative 2 plus negative 3, and then divide that by 5. So that's 2 times negative 5 divided by 5, and negative 5 divided by 5 is negative 1, so 2 times negative 1 is negative 2. Alright, on to D. 3 times x squared, x is a negative 2, so make sure you square the negative, minus 2 times negative 2 plus 1. So negative 2 times negative 2 is a positive 4. Negative 2 times negative 2 on the next part is a positive 4. So it looks like we have 12 plus 4 plus 1, and that would equal 17. Part E, 3 times negative 3, and then all of that is going to be multiplied by x, which is negative 2, plus negative 2 squared, minus negative 3. So a lot just going on in the parentheses and multiplication stuff on this one, so just be careful. 3 times negative 3 on the front would be negative 9, and then we need to simplify what's inside. So negative 2 plus 4 plus 3 Negative 2 plus 4 is 2. 2 plus 3 is 5. Negative 9 times 5 is negative 45. And then on F, negative, and then only the z is being squared, otherwise it would be in parentheses. So it's negative, and then 5 squared times 1 minus 2 times negative 2. And then all of that is being divided by y minus x, which would be negative 3 minus negative 2. So a lot going on here. Let's just be careful. 5 squared is 25. The negative follows, so negative 25. And then we have 1 minus 2 times negative 2, so it'd be 1 plus 4. And then 3, or negative 3 minus negative 2 is plus 2, so that's negative 1. So it looks like we'll get negative 25 times 5 divided by negative 1, or negative 125 divided by negative 1, and that's 125. So a lot going on in that one, but just be careful with doing each of the individual parts as you go along. Question 93, Greta is opening a savings account. She starts with $100 and plans to add $50 each week. Write an equation she can use to calculate the amount of money she will have after any number of weeks. How much money will she have after 1 year? So let's go ahead and write our variables down. Let's let W, since we're looking for per week, equal the number of weeks. And that's our time frame. And then we also need another variable in terms of how much money she has. So let's go ahead and let A equal the amount of money. And that is measured in dollars. So she starts with, that's your initial, and then she plans to add 50 each week, and that's your multiplier, or that's what you're adding, each week. So your equation would be A is equal to the $50 that is being added each week plus the initial $100 that was in the account. So A is equal to 50 W plus 100, or whatever variables you chose. And then how much money will she have after 1 year? Well, 1 year, how many weeks are in a year? And that's 52 weeks in a year. So how much money will we have? We have to take 50 times 52 and then add 100 to that. So we get 2,600 plus 100, and that is 2,700. So make sure we answer the question, how much money will she have after 1 year? Greta will have $2,700 after 1 year. So once again, make sure you're always answering that question and also labeling the $2,700. Question 94. Paula found a partially completed table that her friend Donna was using to determine how fast water evaporated from a bucket during the summer. Every other day, she measured the height of the water remaining in the bucket in centimeters. Complete the table, and then we're going to talk about the rate of change, and then we're going to write an equation to represent the height of the water after any number of days. So we can see that the number of days is increasing by 2 in the table each time. So let's look at the y value, the height in centimeters. It is decreasing by 3 each time. So if we continue to decrease it by 3, that would be 21 centimeters on day 6. And then 18 centimeters on day 8. So that was part A to complete the table. We did that. Part B, we want to know what the rate of change is. Well, since the number of days is increasing by 2, when we find the rate of change, we want the change of y over the change of x. So the change of y is negative 3 over the change of x is 2. So that's negative 1.5. And since we want to answer this including the units, and we want to explain what this means, this is negative 1.5. This would be your y value, which would be centimeters. And then over 1 of your x's, which is the number of days. So the rate of change is negative 1.5 centimeters per day, and that's how much water is evaporating each day. On C, it wants us to write the equation. We have the initial in the table, which is 30, so we have enough to write an equation. So we have y equals negative 1.5 x plus 30. And so that would represent your equation. Once again, your rate of change and your initial is what you need to write your equation.